All right, what's up, class? Sorry that I've been absent. I've been very sick for the last few days, but I'm better, and I do not believe it to be the virus. Um, so today's lesson, or one of today's two lessons, is called a pattern for multiplying binomials. So we've been multiplying binomials for a while now, and we've covered two ways to multiply them. We'll review those at the end of the lesson, but just to get the names in our memory, one of them is by drawing a rectangle and adding the parts of the areas of the rectangle, and the other way is the FOIL method. Okay, so this is going to be a third way. So first we're going to look at these two binomials being multiplied together. X plus 11 and x plus 5. According to the FOIL method, we get x squared for our f plus 5x for our O plus 11x for our I plus 55 for our L. And then the next step is we combine like terms, which we have 5x and 11x because we need the same variable part for them to be like terms. So we get plus 16x plus 55. And now it's completely simplified. But we now only want to look at just the result, the final result. So I'm going to cross this out. Now let's look at this result. What can we say about parts of the result that are related to the numbers we see in our binomials? So, 16. Let's look at the number 16 first. How are those related to the only numbers we see in our multiplication, 11 and 5? Well, 11 plus 5 is equal to 16. And for 55, how is 55 related to 11 and 5? 11 times 5 equals 55. Okay? So this is an interesting relationship. Let's look at a different binomial. A binomial pair. A plus 4 times a plus 6 So we're going to try to apply the relationship we just observed, okay? So we observed that in this binomial pair, these two numbers helped us determine this number and this number. This number through addition and this number through multiplication. So we're going to try that here. Okay, so we got this x squared through the f in our FOIL, so we're just going to get an a squared there. But now we're really just concerned with these two. So without doing any of our other methods, what does 4 plus 6 equal? It equals 10. So 10a, because 4 plus 6 equals 10, plus, what's 6 times 4? Plus 24, because 4 times 6 equals 24. All right? So is that the actual multiplication? Because all we did was apply a pattern we just saw. So now we're going to actually FOIL it to check. FOIL to check. Okay? So a times a is a squared. A times 6 is 6a. 4 times a is 4a. And 6 times 4 is 24. A squared, now we're going to simplify, plus 10a plus 24. So we got the same result. We got the same result using our pattern and using FOIL. So what does that mean for us? What does that mean for us? Well, so far we've seen two examples where we've FOILed twice and we've observed a pattern twice. So we can begin to say that instead of FOILing, when we see a certain pattern, we can just observe that pattern instead, because we know the pattern will be the same as if we did every step of FOIL. We have begun to see patterns like this emerge. Another one is the FL method. Okay. If you don't remember that, go back and find that method, but it's similar. We're looking for a certain pattern that allows us to skip steps of FOIL, so we don't, waste our time doing mundane steps that we know are going to reach the same conclusion in fewer steps. So before we actually explain the pattern, we're going to look at a few more examples. The next one is going to involve subtraction. Okay? These have both involved addition, and now we're going to look at subtraction. This isn't a great whiteboard, but I got to deal with what I have. Okay, so now we're going to look at x minus 5 times x plus 3. Okay? We're going to do it in two ways, just so we can make sure the results are the same in both. So let's try our pattern first before we even try FOILing. Oh, I'm skewed here. Okay, so our pattern again. We're just going to look at the numbers, and that's going to help us come up with those other terms. So x squared is our first term. So now we have minus 5, minus positive 5, and plus positive 3. So we are going to think of this 5 as a negative 5. View as negative 5, even though it's subtracting a positive 5, because we know we can turn subtraction into addition, and if we were to do that here, it would become plus negative 5. Okay? And it's important that we view it as negative 5 because we're going to be adding and multiplying it to this 3 in a minute. We already do this. I'm sure some of you already do this when you're doing FOIL. I just want to explain it for those of you who do not. Okay, so the next part of our pattern is addition. And now we're going to add these together. So what is negative 5 plus 3? It is negative 2. So negative 2x. All right? And now the third term is these two numbers multiply together. We already know that from the last step of FOIL. L, the lasts. So negative 5 times 3, we're going to get negative 15. Okay? We could also have written this way if we had wanted to. Either way is fine. Okay? So this is our new pattern. Let's just double check with FOIL. Okay? So we get x squared plus 3x minus 5x minus 15. Now we're going to combine our like terms, and we're going to get the same result, okay? So what does this tell us? Our pattern works for both addition and subtraction. Okay, so it works for any binomial with addition or subtraction, okay? But now we have to ask ourselves, does it actually work for every single binomial pair that we've seen? So now we're going to look at a new one. The new pair is 2x plus 1 times x plus 5. So we're going to try the new relationship first. Let's try the new relationship first. In our previous 3 examples, the first term is always x squared. We've just assumed it's x squared. But looking at these, we can't say that it's going to be x squared because we know we have a 2x here. So we have to put at least a 2x squared there. Now the pattern. We're going to add these together. 5 plus 1, which is 6x. And then multiply those together, plus 5. Okay? So now we're going to check using FOIL. And we're going to get 2x squared plus 10x plus x plus 5. We get 2x squared plus 11x plus 5. These are not equal. Okay? So why aren't those equal? What does this tell us? We have this 2 here, okay? So new pattern does not work if the first term in either binomial has a number greater than 1. Okay? So that's just a wordy way of saying we have a 2x here. We need both of these terms to only have a 1 there because there's always a 1 implied in front of the variable. Okay, but since there's a 2x here, we know our pattern can't work. So when we come across binomials, we have to use either FOIL or the rectangle method, okay? And by first term I mean the term with the variable. By the first term, I mean the term with the variable. All right? All right, so now we're gonna look at just 2 more examples of when this doesn't work, okay? 2 more examples of when this doesn't work. Okay, so 2x plus 3, 2x plus 5. So this is the same problem as the previous example. We have numbers on these x terms, okay? We can only use the new pattern when these x terms have no numbers, but we have numbers here. Okay, so let's just try it to see how it does not work. So we would get 4x squared, and then using these numbers alone, we would get 5, 6, 7, 8, so 8x plus, what's 5 times 3? 15. Now we're going to FOIL. So we're going to get 4x squared plus 10x plus 6x plus 15. So we get 4x squared plus 16x plus 15. So again, these are not equal. Not equal. Not equal. Okay, so cannot use pattern because of these numbers. Okay, one more example. One more example. So the final example where they don't work, x plus 3. So we already see this is good because the x is alone and we have a 3. And then we have y plus 2. So this variable term's alone and we have a number here, okay? So what's weird about this one is we have 2 different variables. But let's see what we get anyway. Let's just say it's xy, because that's what it would be for FOIL. So we get 3 plus 2, so 5. 5 what? X, y? Let's just say x. And then 3 times 2, which we know is 6. So now we're going to FOIL. We're going to get xy plus 2x plus 3y plus 6. Okay, we can't combine any terms because there's no like terms. And these are not equal. not equal. Okay? But we see that 2 plus 3 does equal 5, but they're not like terms, so we can't add them. So cannot use pattern because these variables are not the same. Okay, cannot use pattern because these variables are not the same. All right, so you should now have enough tools to move on to the handout for this. I'm just going to briefly explain or sum up everything we've done in this lesson. So, new pattern. Third way to multiply binomial pairs. The first term is f from FOIL. The second term is the numbers added together with the variable term added. The third term is the two numbers multiplied together. Okay? Does not work if the variables in the binomials have numbers or are not the same variable. All right, so attempt the handout, and the answers for the handout will be posted later. Reach out to us if you have any questions.